everyone. Today I'm going to be talking to you about the Marburg virus. Let's first take a look at some background information about this virus. First, I'm going to tell you exactly what it is, how did it come about, and lastly, where did it come from. So what exactly is Marburg virus? The Marburg virus is a member of the Filovirdae family, which also consists of species known as the Ebola virus, Qvio virus, and Thermanovirus. Each of these viruses is responsible for causing hemorrhagic fever. This is a type of illness and is an infectious disease that is responsible for the blood's inability to clot. When the blood of a human is unable to clot, it is often in terms lethal. Now let's take a look at how did it come about. There are many different theories of exactly how this virus came about and where it exactly came from. According to the Virology Journal, the Marburg virus was first discovered in 1967 in the countries of Germany and Yugoslavia, which is now known as Serbia. The Marburg virus came to known to the public and later in 1999 when an outbreak occurred in the Democratic of Congo. This massive outbreak ended up impacting many different lives of different people and it had a fatality rate of 83%. The largest documented outbreak of the Marburg virus occurred in the year of 2005 when 252 people were recorded with infections. And 227 of those ended up dying, according to Shiflett and Marzi. Because of all these deaths, different governments tried to figure out exactly how this all happened. And after the initial part of the investigation, different organizations found out that the patients that were infected with this virus had been working around the Kitaka mine in the Ibanda district of the country. So where did it actually come from? Multiple different bat species are associated with being a host for different flaviviruses. Evidence supports that the Egyptian fruit bat serves as a host for the Marburg virus. When this bat is infected with the disease, it shows no symptoms at all. The Egyptian russet bat can often obtain lifelong immunity following recovering from the primary infection of the virus. They can show no symptoms of the disease but can still carry the virus. The bats shed the virus within their feces, which can be inhaled when humans come in close contact without protection. This could potentially be a problem because humans could come in contact with the virus without even knowing it. And this is to believe why it spread so fast after the humans encountered the virus is because they had no idea that they had even been in contact with the virus because many of those people in the Ibanda district actually just lived outside of the mine. They actually didn't go inside and were working in the mine where the bats actually were. So let's take a look at the connection to human health. How is it transmitted? Different signs and symptoms. What is the type of treatment? And environmental health. So how is it transmitted? So as we know, like how it is transmitted from bat to human is through feces, but human to human it is often transmitted aerosolly, so with droplets in the air. And once it is inside the host of the human, the infection becomes amplified, and then it can also be transmitted through bodily fluids such as sneezing, coughing, all that kind of stuff. So now let's take a look at treatment. Scientists have begun testing individuals once they have been infected with the flavivirus by injecting them with antibodies to help their response to the infection. During this time, during the 2013 to 2016 Ebola outbreak, another virus which is similar to the Marburg virus, and it's a member of the Filovirdae family, scientists began treating the individuals with covalent plasma. With the efforts of the scientists trying new remedies to treat the virus could not be related to those of the Marburg virus. And the types of plasma that they were injecting showed no signs or improvement in the quality of life of those that had been infected with the flavivirus. Because of the different types of flaviviruses and their high rates of transmission, scientists have had a hard time conducting human trials to test different vaccines and their effects on the host. Experiments must be done ethically, so when testing on an animal, the virus must reflect human pathogenesis. At this time, there's no sufficient form of treatment for the Marburg virus. Scientists are still trying to figure out a way to conduct trials on humans to see what types of vaccines and drugs could help kill the virus by attacking the different proteins of the virus, causing them to malfunction, and then allowing the body to fight off the virus. So now, and also the only way that scientists can just keep the patient that has this virus is to keep them comfortable and keep them hydrated, and also give them medicine that helps the body's ability to clot. So now let's take a look at the environmental impact. The problem with this virus is that it is considered a biological foreign agent because of its high mortality rate and the ways of transmission, and along with the absence of vaccines to treat this type of infection. Also, this virus is extremely contagious when it comes within human-to-human contact, and so that gives people a cause of fear because they're afraid that they will come in contact with this virus. This virus can easily be transmitted from human to human and has a high mortality rate. Vaccines and antibiotics cannot destroy this virus, and scientists have a hard time conducting research on humans because of ethical reasons. In the short time of an individual has before death occurs, the virus enters the body. I hope with the advancements of technology we can find a treatment for those that are impacted by the Marburg virus. And here are my sources, and thank you for watching my presentation.